Swayam Prabha. Digital India. Educated India.
Good morning. Once again, I welcome you all in this lecture, soil mechanics lecture, and we are now still we are in third week, and topic I have just started compaction of soil, and some of the aspects already I have discussed on compaction, and there I have tried to show that every soil will have a particular compaction characteristics curve, and that curve generally variation with moisture content, dry density, and we have seen that for every soil there is and for a particular energy level there is a particular maximum dry density and for a particular moisture content, and also we have shown some of the things with energy. If we increase, then your dry density increases with but at a lesser effort, that means with less amount of energy water moisture. Like that, for different soil also we have seen different moisture density relationship. When the soil is finer, then more moisture required, but we achieve less dry density. So, these are the things we have discussed, and one thing I just remind you that this moisture density characteristics are applicable when the soil contains some amount of plasticity. That means, when there is a silt, clay are present, then this is valid, but when it is a completely cohesionless soil, then this moisture density relationship what we see or what we have shown, it is not applicable. In fact, hardly there is a variation with moisture content in soil, granular soil. In fact, for a very small amount of moisture water at the initial stage, it will have some change, and particularly at completely dry, it will have very high density, dry density, dry density, and with the increase of moisture content 1 or 2% because of this bulking effect, there will be slight reduction in dry density, and again when you further increase the water, suppose that bulking is maximum at 4% and 3 to 4%, and further increase of water, that bulking effect will vanish, and then again at a complete saturation the sand will reach to its maximum density. Again, if you add water more than the saturation condition, then that will be again a little decrease also. So, if you typically see the curve, generally it's generally if it is having like this, it is gamma d. So, for sand it comes like this and is like this. So, this variation is again not very large, and this water content also is not a very large range, is within a small range only. It changes only beyond 4%, those effect goes, and then we will get at saturation we will get the maximum dry density. So, this whatever moisture density characteristics we have shown for a soil, that is applicable when soil contains some amount of plasticity, that is silt and clay. Now, we will discuss further. We have seen that there is a definite amount of moisture required for achieving maximum dry density, but there is some situation that there are various application, and particularly in the field, whatever you have achieved in the lab exactly will not be able to achieve. So, in that case, what are the ranges which we can do to achieve satisfactory result? So, for this actually we have shown this table. You can see here actually it is shown different types of work like road with 0 to 5 meter, road with greater than 5 meter, small earth dam, large dam, embankment, foundation, wall, trench, clay liner, different types of works where we do this type of compaction which I have discussed, that is shallow compaction or densification by roller and other equipment. And in that actually percent of modified maximum dry density, that is 90 to 105. That means how much, whatever dry density you get, how much you should at least achieve. So, we can achieve 90 to 105. So, that means less or more also. And in road, if it is 90 to 95, small earth dam 90 to 95, most of the cases actually approximately 95% is the most common work, where actually whatever we get in the laboratory, we should at least able to achieve 95% of that. Most of the, this is the specification generally will give in terms of Proctor compaction, that you have to compact with a Proctor density 95% of Proctor density, 98% of Proctor density, like that. And similarly, similar to that maximum dry density, there is also moisture content variation. So, because you may get in the laboratory 15.2 percent water content maximum dry density, but in the field we will not be able to achieve that exactly. In that case, we have to put some range. So, that range, maximum permissible range for different work, it is given for the small earth dam, it can be -1 to +3%, that -1 means less than optimum -1%, and plus means more than +3% optimum. Similarly, for large dam -1 to 2, for embankment -2 to 2, and it is foundation -2 to 2, again like that, all variations. So, these are the things, guidelines actually when you do in when you practice these compaction activities in the field, these are the things one has to keep in mind. Next, this actually partly I have told perhaps in the my previous lecture, that different equipment, compaction equipment we may have, but how to select that, and if you select that, what will be the lip thickness and what will be the number of passes. This is the for different rollers, actually it is shown here. You can see that if it is a ship foot roller, then what type of soil you can apply for fine grained fields or coarse grained fields with more than 20% fine. That means, when silty when fine soil is present, then only we go for ship foot roller. So, that is the requirement shown here, and when you compact this type of soil, you have to use a lip thickness of 150 millimeter, that means 6 inches approximately, and how many passes depends on how much dry density you want to achieve. Sometimes 4 to 6 passes for fine grained fields and 6 to 8% for coarse grained fields. Similarly, rubber tire roller, this is clean coarse grained fields actually with 4 to 5% fine, then we can use a 250 millimeter of lip thickness, that is around 10 inches, and it will have to given 3 to 5 passes. Similarly, if it is rubber tire roller when used for fine grained fields or well graded coarse grained fields, then with 8% fine, then we can vary the lip thickness between 150 to 200 millimeter and pass 4 to 6 passes. Similarly, smooth wheel rollers appropriate for subgrade and base course compaction of well graded sand gravel mixture, and this is in fact we can go for a lip thickness of 200 to 300, and how many passes you have to give? You have to give 4 passes, like that it is go on. Next, there are some more roller type, that is vibrating smooth wheel roller, as I have mentioned, that is used for coarse grained soil. For coarse grained fields and sand gravel mixture, generally this vibrating roller is required. Why it is? Because of vibration, then particle arrangement is possible, otherwise that granular soil by just impact given pressure, the particles cannot be brought closer. So, in that type of soil, the lip thickness can be used 200 to 3 millimeter for soil and 900 millimeter for rock, and how many passes required? 4 to 6. And vibrating plate compactors for coarse grained fields with less than 4 to 8% fine, and lip thickness will be 200 to 250 and number of passes 3 to 4. Then crawl tractor, power temper or like that, there are some more applications are there. They have lip thickness 150 to 250, 3 to 4 passes. Here 100 to 150 for silt or clay 2 passes, and again 150 for coarse grain fields, that is there also 2 passes. So, these are actually some guidelines when you will be in practicing this compaction work, then you need to select appropriate equipment based on soil type. And not only soil type, that soil has to be tested in the laboratory, and then you have to find out optimum moisture content, dry density, then you have to decide what dry density and moisture content to be used in the field, and then we have to monitor, and then based on that you have to select equipment, and then after selecting in addition to the selection of equipment, you have to also give requirement how many passes, because contractors ultimately will be doing this job and they should know what they have to do. And this is compaction. The conventional compaction actually is used for earthworks, the road, embankments, dams, slope, parking lots and sports field. These are the areas actually commonly that type of compaction equipment I have mentioned, they are used for this type of work mostly. And it has some advantages and it has some disadvantages. What are the advantages? Advantages are construction equipment is readily available, that with this type of roller and whatever I have mentioned, they are very easily available and it is well established. Since long people are using for compacting the soil this type of method, and extensive knowledge in the industry. The people are having knowledge also what to use, how to use, and which will be effective, which is not effective, all those things actually contractors know well. So, that is the advantage, and there are some limitations also. If I do this type of compaction or compaction equipment, the roller and all, you get actually very thin compaction, that is the depth is not much, it does effect will not go much. Because of that, in fact, we are doing a particular lip thickness and mainly used for field and not for in situ natural geomaterials. So, in situ suppose kilometers of kilometer land, suppose you have to improve, then by using roller may not be a practical work. And then geomaterial should be within the moisture content. These are the limitation actually. We want to compact, that whatever borrow material we will be getting, that material should be close to optimum moisture content also, otherwise you have to add water. So, these are all you can say disadvantages, and it is challenging to achieve uniform compaction by this. Obviously, the roller sometimes they will make back and forth motion, and then sometimes will not be able to go partly, sometimes will go fully. So, like that may be not a very uniform compaction over the entire area which is desired actually. So, these are the few limitations. And then another thing is as I have mentioned, that when we change the level of energy, then automatically what happens, your compaction curve shifting left and with higher dry density, like you have one compaction curve for a particular soil with this much energy, the another is second level of energy, there is another third level of energy. So, everywhere actually we are shifting left and with higher dry density. And suppose in my requirement is some gamma d, which is actually this one, and I have drawn a line from here to here, and with 3 compaction curve with 3 different energy level is drawn here, and then my required dry density I made a horizontal line. And you can see that the lowest energy level, the compaction curve is actually below the requirement, that means we cannot choose that energy. So, and other case actually there is a energy level 2 and 3, they are actually intersecting my required dry density. So, that means we can choose either this and this, and if you choose this one energy level 2, then your moisture range actually narrow from here to here, and that means if you vary the moisture between this and compact, then I will be able to achieve with this much energy your required dry density. Similarly, if you use this energy level, then you have a wide range of moisture content from here to here, and that means between this to this much water, any amount if you add and compact. So, you will get the dry density greater than your or greater than or equal to your required dry density. So, these are the things sometime you have to do some trial with different energy level, you have to draw compaction curve, then you have to see your requirement, and then finally, you have to decide how much you can vary in the water and how much dry density you can vary in the field, those things to be decided. Similarly, here sometime we have some compaction curve of different energy level, and suppose by one point method also sometime we can find out what will be the optimum moisture content. So, if I have suppose a curve with one energy level, I have another curve with another energy level, but I neither use this energy nor use this energy, then I have to use some other energy, and by that energy if you can draw or you can conduct one test and find out a point, and that can be imaginary compaction curve taking with respect to this can be drawn, and from there we can actually find out the optimum moisture content. How? Suppose the imaginary the one point where dry density and moisture content, if you plot in this, it comes suppose here, and then since the trend of curve like this. So, if the energy level is between this and close to this, then I can draw a curve, approximate curve passing through this point, and you can see you know that it shifts parallelly the left side. So, we have done so, and after completing this curve I can now tangent I can draw here and it can draw here. So, this will be the desired water content, this will be the desired dry density. So, that way also can be obtained sometime in the field. This is also another technique sometime can be used. So, different energy level we have conducted the test, and corresponding dry density we have got. Suppose this is one point with energy 1 and this is another point energy 2. So, these 2 points are actually plotted and it is a log curve. It is observed that it is a straight line, and then this curve we have, and if you want to use some other energy corresponding dry density and energy, suppose if it is plotted like this versus this and this versus this, and now suppose I will use some other energy somewhere here, then I will produce on this, and then from here I can get the what is the dry density I can achieve with this much variation of energy. So, that also can be sometime can be obtained in the based on if you have already some data, and because these are all standard energy suppose, and if you want some other non standard energy, then and or sometime some definite energy, for that corresponding to that energy what will be the dry density can be achieved, that can be obtained by this. This is another, of course, we can have different energy level curve here, and from there actually again we can put our obtained one point from here. From here obviously you can, they are all very close lines. So, automatically the curve will fall somewhere here. So, from here also one can find out optimum. So, if you have the master curve like that for a same soil for different energy, if you have this plot, then if you do one test with different energy, that can come somewhere here also slightly here below. So, then I can draw a curve like this, and then from there I can find out optimum moisture content and dry density. And then recommended number of tests, that means if you how many tests you have to do, this is the thing actually. It is embankment work. If it is embankment work, then 500 to 2000 meter cube of work one test at least has to be done. If it is impermeable liner, So, 200 to 1000 meter cube work you have to do one test at least, that is control test. Then if it is subgrade work, this is the one 500 to, if it is a base course 500 to 1000, and if it is a backfill in trench then 100 to 200, that means this much volume of work you have to test. Otherwise, this is a by which actually you can do the quality control. And this quality control and assurance, that is very important, because compaction work mostly done this way, like this is first of all you have to select, if there is suppose road will be constructed, then first road alignment will be fixed, and then dimension will be fixed, and then nearby there will be borrow pit will be fixed. There are several locations may be available, and based on that you have to collect the soil from different sites and then test, and then considering several aspect, transport cost, material cost, and moisture content, optimum dry density to be obtained. Based on all those things you have to select one or two, and after selecting that, so it will be excavated, transported by truck and put it in the construction site, and then it will be sprayed in desired lip thickness, and then it will be roller, put roller, and if there is a moisture requirement, then water will be sprinkled over it. So, this is the way work done, but this work actually when the large amount of work to be conducted completed, and then several workers will be working there, and sometime quality that means as desired sometime may not be maintained. So, that for that actually grossly you have to check time to time what is the compaction achieved, and then only you have to certify that it is done and you go to the next. So, like that for quality control this type of work is very important, and for this quality control work important for conventional compaction, because it often involves large area construction. Quality control typically include the following: quality of field material, whether right material is chosen, the type, gradation, and error bug limits. So, because you are using suppose shipwood roller, but there is no plastic, it is a sand, or it is sand and only smooth wheel roller is used, then we will not be correct. So, all those things to be checked. Then type and weight of equipment that you have to see. Then lip thickness, that has to be seen, because it is recommended that it every 250 millimeter of lip thickness to be used, but if it is instead of that 400 600 lip thickness, then compaction will not be enough. Then moisture content and at compaction, again moisture content is very important to achieve the optimal dry density. If the moisture content is less than that or more than that, you will not get, only within the range only we get. So, that has to be seen, whether when what are required to be sprayed sprinkled, whether they are doing or not, that to be seen, and number of passes, that is also very important. If recommended 4 passes, but if it is doing more or less, both are not correct sometime. So, quality assurance is achieved through field test after each lift compaction and or completion of the overall of compaction. So, every lift, so long distance or 200 millimeter suppose thick layer will be compacted, and after completion of that stage one can do a field compaction test, density test, and then finally ensure that required dry density is achieved. So, for that actually there are number of methods are there. Sand cone method, there is a method called sand cone method, then to find out density, the rubber balloon, nuclear gauge, dynamic cone penetrometer, soil stiffness gauge. There are so many equipment nowadays available, but typically most easy way easiest way actually what we can do, that sand replacement method, that we make a hole or pit in the site, collect the soil, and you find out the weight and moisture content. If you can find out the then whatever peat we make, suppose there is a ground surface is that peat is made something like this, and if you the peat generally you cannot make such a irregular such a regular shape, maybe some irregular shape. So, you have to find out this volume. This volume generally determined by filling by sand, and that sand actually having definite density. So, how much sand has gone here and weight to be taken, and if I know the density, then this by gamma you get the volume. So, once you get the weight divided by this volume will give you the bulk density, and bulk density divided by water 1 plus W will give you the dry density. That way actually easiest way we can do, but for doing this actually we need 1 day time minimum, because to determine the moisture you have to keep it in oven and at least 24 hours you have to wait. So, for that nowadays many alternatives are there, actually you can do directly in the field, and one such method is that is non-destructive method. They are actually there is a one such method is shown here, nuclear moisture density meter, like that in the field directly we can get the moisture and density. And how this may work, actually the apparatus is placed on the ground or compacted field and emits gamma rays through the soil. Some of the gamma rays will be absorbed, others will reach to a detector, and soil unit weight is inversely proportional to the amount of radiation that reaches the detector. So, that is the way it works, and it also can sometime measure the moisture. So, how nuclear apparatus also determines moisture content by emitting alpha particles that bombard a beryllium target, causing the beryllium to emit fast neutrons, and fast neutrons that strike hydrogen atoms in water molecules lose velocity. The resulting low velocity neutrons are thermal neutrons. Based on the thermal neutron counts and proper correlation, soil moisture can be also do. So, this is the equipment nowadays directly we can do, and time to time we have to calibrate whatever based on this count you are, since you are doing. So, whether they are doing correctly or not, that has to be calibrated time to time. So, then there is a nowadays we have a intelligent compaction. That intelligent compaction means that equipment itself will have some various accessories which actually can monitor the or through some sensor it can find out what is the amount of moisture, what is the amount of density achieved, all those things you can, and it will direct and you where actually it is weak, and you have to repeat the work. So, this is the typical intelligent compaction equipment, and it will have, see these are the number of things shown here, GPS linked, and then it is having onboard computer display unit from where you can see GPS reference color coded compaction value, like that. So, many accessories will be there, and this type of equipment of course not readily available. It has lot of advantage because we can find out the weak places by itself and we can do additional compaction, but it is not readily available. Also expert operators are required. So, lot of disadvantages are there. So, basic concept of intelligent compactor is, you can see the intelligent compaction is a continuous construction technique with quality assurance and control processes incorporated in the construction. This technique includes automatic measurements of geomaterials properties through pre-installed sensors on the machine, and adjustment and optimization of the vibration amplitude, frequency and or speed using a feedback control system by the machine operator to achieve uniform compaction and desired target values. So, these are things information to be fed, and it will also receive information, and then where there is a mismatch it will instruct you to do those. And suitability is same as conventional compaction equipment, it will be useful, but additional advantage that you do not have to do any quality control separately. And advantage will be you can see the IC, that way intelligent compaction method has the measurement and feedback system which helps the operator identify weak spots for further compaction or treatment and quality control or quality assurance, avoid over compaction and reduce the number of passes. So, suppose though we have recommended 6 passes for a particular dry density, but if I find that at 4 passes we are achieving that, then we can stop. That is the advantage. The intelligent compaction method can serve as a full coverage of QC, quality control and quality assurance, and minimize the need for field inspection. it can result in more efficient and uniform compaction. So, these are the beauty of this equipment, but this equipment currently is not very expensive and than conventional equipment, and it requires managing and analyzing a significant amount of data. The method often requires test strips for calibration of target compaction values prior to production. So, these are the few things you have to know, and there are specialized people also required for handling this equipment. So, with this this compaction, I will just close this shallow densification, and I will take another topic on compaction, that is dynamic compaction. Sometime if you want to go deeper, then this is not sufficient. So, we have to use some other technique, that is called deep dynamic compaction, which I will discuss in my next lecture. Thank you.